Hello and welcome to another video. In today's video, we will be going over a past grade 8 exam paper set by the Department of Education. In this test, the following topics are covered: geometry of straight lines, simplifying expressions, solving equations, and properties of triangles. This is term 3 work. So if you are in term 3 and you are in grade 8, this video is the perfect preparation for your exams. In the first question, we have simplifying of expressions. If we look at 1.1, we have to simplify the following. So the first question is quite a basic algebraic expression. In this, we have to identify the like terms, and 3x and negative 9x are like terms. So we're going to put those two terms next to each other. And then plus 7y plus 4y are like terms as well there with them. 3x minus 9x, that is negative 6x plus 11y. That is it for the first question. In the next question, we have subtract 2x minus 3 from 2 plus 5x. In this expression, we are subtracting 2. In the next question, we have subtract 2x minus 3 from 2 plus 5x. We are subtracting an expression from another expression. So when we do that, we are subtracting 2x minus 3 from 2 plus 5x. So we start with 2 plus 5x. When we do subtract expression from another expression, we subtract and we put the second expression in brackets. Okay, like that. And then from there, we simplify. There's a negative outside of a bracket. We know that when that's the case, the signs inside the bracket change. Then we always look for like terms. If we see like terms, we group them together. But I'm going to skip that step. 5x minus 2x is 3x. And then 2 plus 3 is plus 5. That's the final answer over there. Because 5x and minus 2x is like terms. Okay, that gave us 3x. And then 2 plus 3 gave us the 5. In the next question, we have to simplify, but it's a fraction. So we can see that on the top of that fraction is 3 terms. However, before you can simplify that over there and subtract terms, ask yourself, are they like terms? The variables might be the same, but the exponents are different. Therefore, they are not like terms. In this case over here, when we are dividing, since they are not like terms, we will start off by dividing every term by the denominator. We start off with 12x to the power of 3 divided by 3x minus 6x squared divided by 3x plus 3x divided by 3x. So every term at the top has been divided separately by the denominator. Okay, then 12 divided by 3, that is 4. When we are dividing variables, we know that if there is no number at the exponent, that number is 1. 3 minus 1 is 2. We have the same letter, so when we're dividing the same letter or variable, we subtract the exponents. So that's why we're saying 3 minus 1 gives us 2. Bring that minus down. 6 divided by 3 is 2. Same process, 2 minus 1. That gives us x to the power of 1. Then over there, we have 3x over 3x. We have the same over the same. In that case, it cancels. So 5 over 5 would be 1, 10 over 10 would be 1, and 3x over 3x would be 1. We divide the same number by itself, the answer is always 1. That is your answer. You cannot go any further because they are not like terms. In the next question, we have simplifying, but there's a square root. So, if we look underneath that square root, we can see that there are like terms. The moment you see like terms, you simplify those like terms. So, these two terms are still under the square root. So when you add them, 16x squared plus 9x squared is 25x squared. And the plus 3x is outside of the square root. And again, we find the square root of 25, which is 5. And in this case, the root, square root, and the square are inverses, so they would cancel, and you would be left with just x plus 3x. Now you wouldn't stop here, because as you can see, these are like terms, so you end off with a final answer of 8x. In the next question, we have 2x to the power of 3 plus 3y to the power of 2 minus 1. Now in this case now, we are knowing the values of x and y, so it's going to work a bit different. We know that x is equal to -1, and we know that y is equal to 2 because they are telling us that. So in this case, when we know the variable, we're going to substitute the number that we know in brackets. So we have 2, and we're going to replace this x in brackets with -1. Note that the exponent is outside the bracket, plus 3 brackets 2 squared minus 1. Okay, I replace this y with a 2 in brackets, and note the square is outside the bracket. Then we simplify the bracket. -1 to the power of 3 is -1 times -1, which is 1, times -1, which is -1, plus 3 brackets 2 squared is 4 minus 1, and then the number outside the bracket we're going to multiply. That gives us -2 plus 12 minus 1, and then our final answer, these are all like terms. -2 plus 12 is 10, minus 1 is 9. Okay, note that when there's a number next to a bracket, we multiply that number inside the bracket. In the next question, we have solve for x in each of the following equations. Okay, now we are solving for x, and we have ourselves an equation now. When it comes to the equation, we always think about inverse. So we have x plus 7 equals to 12. We want to have x on its own. We're going to say x equals to 12, and the inverse of plus 7 is -7. Therefore, x is equal to 5. In the next question, we have a fraction. Okay, in this case, all that fraction means is we're going to do the inverse of dividing. So we have 4x minus 2 divided by 5 equals to 2. It's quite simple. That says divided by 5. The inverse of divided by 5 is multiplied by 5. So what we do in this case is we multiply both sides by 5. And initially this cancels because 5 divided by 5 is 1. And we have 4x minus 2 equals to 10 because 2x times 5. Same thing over here that we had in the previous question. We're going to have 4x equals to 10, and the inverse of -2 is plus 2, and we have 4x equals to 12. In this case, we divide by the 4 because this says 4 times x. So we divide now, and then x is equal to 3. Alright, In the next question, this is very critical. The unknown variable, or x, is now an exponent. So this is going to work a bit differently. So when x is at an exponent, we look at this 3. This 3 is a base. Okay, it's critical to change this 81 to also have a base of 3. So we need to rewrite this 81 to have a base of 3 and a certain exponent. What you can do is put 81 into your calculator, press equal, press shift, and press the factorize button or the FACT button. So you will end up with 3 to the power of x plus 1 equals to 3 to the power of 4. In this case now, the bases are the same. The reason I can rewrite this 81 like this is because 3 to the power of 4 equals to 81. Now that the bases are the same, I can equal my exponent on the left side to the exponent on the right. And I find myself having another equation, which is quite basic. We do the inverse of plus 1 on the other side, and we get 3. In question 2, we move over to straight line geometry. Now, in 2.1, they want you to write down the complement of 35. Now, do not be confused because now they are using the word complement. The word complement simply means what do you need to add to 35 to get to 90 degrees? And in 2.2, write down the supplement. The word supplement simply means what do you need to add to 89 to get to 180 degrees. So, to find that answer, we're going to say 90 minus 35 is equal to 55 degrees. In the same breath over here, we can say 180 minus 89 equals to 91 degrees. So the complement is 55 of 35 and the supplement of 89 is 91. For the next question, we have calculate with reasons the size of the following, or the size of the unknown angles. The first unknown angle is angle A over there. We can see that that's a straight line and it has been split up into 3 different angles. So to find that, we know the property of a straight line is that adding all the angles in a straight line equals to 180. So this angle A plus this angle, that symbol we should know is 90 degrees, and plus that angle 39 degrees. Adding all those angles equals to 180 degrees, and we need to accompany with reason, as each region is worth 1 mark. The correct reason: angles on a straight line equal 180 degrees. From that, we have an equation, and to find A, we're going to do the inverse of 90 and 39. We have A equals to 180 degrees minus 90 degrees minus 39 degrees. Okay, then we have A equals to 51 degrees. That's quite simple. That should be 3 marks. In the next question, we have a diagram over there, and we need to find A, B, and C. Okay, and for us to find the angle, we need to take an angle that we know and form corresponding co-interior, vertically opposite, or alternating angles with the angle that we're trying to find. So let us start with A. We can see that 140 degrees and A are forming a co-interior. So what do we know about co-interior? We know that when we add the angles of co-interior, A plus 140 degrees, it equals to 180 degrees. Our reason is co-interior angles. Again, we have an equation, 140. We will write the inverse on the other side, and A is equal to 40 degrees. We can then replace this A with 40. B is quite simple. We can see that it is vertically opposite. So B is equal to 140 degrees because the angle are simply vertically opposite. And then for C, there's a few ways to do C. Okay, we know B now. It's 140. Okay. There's a few ways to do C. Okay. There is corresponding. There is straight line. And there also is alternating angles to do C. Whichever one suits you. I'm going to go with C equals to 140 degrees because of corresponding angles. Okay. In the next question, again, we have a straight line and it is split into two different angles. You apply the same principle, adding the angles in a straight line equals to 180 degrees. However, in this case, it's a bit more complicated as we have more than one term, but it does not change anything. So we take that angle, 3x minus 30 degrees, and we add it to that angle, plus x plus 10 degrees, and that equals to 180 degrees. You have to write your reason. It's always worth 1 mark every single time. Angles on straight line. Okay. From that, again, we have an equation. Okay, and we're going to solve this equation. Okay, we have 3x, and we're gonna put like terms together, equals to 180, and you're going to take the minus 30 and the plus 10 as inverses, so it is plus 30 and minus 10 degrees. Then you have 4x is equal to 200 degrees over there, and then we divide by the 4, x is equal to 50 degrees. In the next question, we are tested a bit more and a bit extensively. However, if you remain calm, you can see that there are alternating angles, corresponding angles, and co-interior. So do not panic. Firstly, we can see the angle 6x plus 10, and we can see the angle 70. We can see alternating angles there. We're trying to find x, so the key is to look for the angle that has x in it with an angle that has a known angle. We're not going to use 80 because there are no letters corresponding, alternating, vertically opposite that are worth at 80 degrees. If there was an angle here, you could have had a triangle and solved for x there, but you don't. So you can choose something else, and you have alternating angles. So you're going to say 6x plus 10 degrees equals to 70. Okay, this is an equation. You need a reason always. The reason is alternating angles. Okay, then you solve this equation doing the inverse. 6x equals to 70 minus 10, 6x equals to 60, and then you divide by 6, x is equal to 10 degrees. Okay, going a bit faster because it's a simple equation. You can watch it 0.5 speed if that was too fast. Okay, but yes, that's how you do it. Now we know that x is equal to 10. Now that we know x is equal to 10, we're going to substitute 10 in here, and that is going to equal 70, like we just said, that angle over there is equal to 70 degrees. So I'm simply going to change that. Okay, and then that is now 70 degrees. Okay, now to find y, it's going to take a bit of a tricky eye to find y, but you can see that this angle 80 and these two angles over here are forming co-interior angles. So if you add 80 plus 70 plus y, which is all these angles inside the co-interior, it equals to 180 degrees. Your reason, co-interior. Now you have an equation. Y is equal to 180. We're going to have the inverse of 80 and 70. And y is equal to 30 degrees. In question 3, they want us to calculate with reasons the size of the following unknown angles. Question 3 consists of triangle properties. We are looking for A, and we can see that A is forming part of a triangle with 50 and 100, which is two known angles. From that, to find A, we can create an equation. A plus 50 plus 100 is equal to 180 degrees, and your reason is angles in a triangle equal 180 degrees. Always write the reason. Then from this again you have an equation. A is equal to, you're going to write the inverse of 50 and 100, and A is equal to 30 degrees. You can replace this A with 30 degrees. Okay, now there are two ways to find B. One is you can use the straight line property. Those two angles B and 30, if you add them, they equal to 180 degrees. But I want us to make use of a different triangle property that you were taught, is that B is an exterior angle of that triangle. So the exterior angle is equal to the two interior opposite angles added. So B is equal to 50 degrees plus 100 degrees. Those are the two interior opposite angles, and B is equal to 150. What's missing over here? Yes, you've spotted it, so you've missed your reason. Your reason is exterior angles. In question 3.2, we have ourselves a nice triangle, and in a way, you have been simplified to the possibilities of what you need to do. We need to calculate the value of x. We see that all three angles has the value x, and there's only really one thing to do. We're going to add all those angles. Angle G, x, plus angle H, which is 2x plus 40, plus angle J, plus x plus 20, and adding them all up to 180 degrees. And your reason is angles in a triangle. You need to add that in brackets, but due to space I'm not going to, which means I would lose one mark. Angles in a triangle equal to 180 degrees. That means I'm going to get 49 out of 50. Okay, so my like terms are x plus 2x plus x equals to 180, and my 40 inverse over there as well. This becomes 4x, and 180 minus 40 is 140, minus 20 is 120 degrees. So 4x equals to 120 degrees. Then we divide by 4, x is equal to 30 degrees. In the next question, we need to now determine the value of each angle. We're going to use our previous information that we just learned from the previous question, is that x is equal to 30 degrees. So we start off with angle G. Angle G is simply x, which means angle G is simply 30 degrees. Okay, angle H. Angle H is 2x plus 40 degrees. Now remember, in the previous simplifying expressions previously in the question paper, we now know the value of x. We're going to substitute that in brackets. That 30 we know is x is in there, so it's 2 times 30, which is 60, plus 40, which is equal to 100 degrees. So angle H is equal to 100 degrees. Then angle J is equal to x plus 20 degrees, which is simply 30, since 30 is x and x is 30, plus 20. That is equal to 50 degrees for angle J. Okay. Now we have the value of each angle. G is 30 degrees. Okay, I can replace that x with 30 degrees over there. I can now replace that angle H with 100 degrees, and I can replace J with 50 degrees. I have the value of each angle now. Now, we have the value of each of the angles. In the next question wants us to name the triangle above. We can see, or we can look at the angles to be able to determine the type of triangle that we have, and we see that there are no equal angles. Therefore, this type of triangle is a scalene triangle. That is it. I hope all the best for your exam paper and that you get full marks for your exam. Thank you for watching.